Welcome to Brain Vision.
Okay, so here we have a classic question asking us to determine the concentration of acid, base, and pH for each of the strong acids given. So let's dive in and we'll walk through each step of the process to find the solution. The first thing to note about dealing with strong acids is that they dissociate completely in solution. So the molar concentration given for HCl is also the concentration of hydrogen ion in solution, which gives us the answer to the first part of the question. H3O plus is equal to 0.25 molar. To find the pH of the solution, we take the negative log of the concentration of hydrogen ion in solution. Which comes out to 0.60 pH. Now, given that the sum of the pH and pOH is always equal to 14, we can determine the pOH of solution by subtracting the pH from 14. pOH equals 14 minus the pH, which comes out to 13.40. The concentration of base in solution can be found by reversing the negative log. This is done by taking the value of 10 to the negative pOH of solution. The concentration of base is equal to 10 to the negative pOH of solution. Which comes out to 3.98 times 10 to the negative 14th molar. Moving on to part B, we first notice that nitric acid is also a strong acid, and so the process for solving this problem is the same as part A. Concentration of acid in solution is 0.015 molar. The pH equals the negative log of hydrogen ion concentration, which equals 1.82. pOH is equal to 14 minus the pH, which is equal to 12.18. And the concentration of base is equal to 10 to the negative pOH, which comes out to 6.61 times 10 to the negative 13th. Part C tries to throw us a curveball by giving us two different acids that are mixed in the same solution. But since these are both strong acids that both dissociate completely in aqueous solution, we can simply treat them as one acid by adding the values together to determine the hydrogen ion concentration. So this gives us H plus equals 0.052 molar plus 0.020, 0.072 molar. From here, it's the same process as before. pH equals negative log of the hydrogen ion concentration, which comes out to 1.14. pOH is equal to 14 minus the pH, which comes out to 12.86. And the concentration of base is equal to 10 to the negative POH. Which equals 1.38 times 10 to the negative 13th molar. The last part of the question gives us a percent of acid by mass, a density for the solution, but no molarity to work with. So to solve this problem, we need to first determine the molarity. To do that, we need to begin by converting our units to match with that of molarity. So the units for molarity are moles per liter, and the density is given in grams per milliliter. So we need to convert milliliters to liters. So we take our density of 1.01 grams HNO3 per 1 milliliter, and we multiply that by 1,000 milliliters per liter. We cross out the milliliters, and we get 1,010 grams HNO3 per liter. Now that we have the grams per 1 liter of solution, we can find the mass by multiplying by the percent of nitric acid in solution. So we have 1,010 grams nitric acid per 1 liter. We multiply this by the percent. 0.00655, and this equals 6.62 grams per liter of nitric acid. Now that we have the mass in 1 liter of solution, we can find the molarity by dividing by the molecular mass of nitric acid. So we take 6.62 grams nitric acid per liter and multiply by the molecular mass, which is 63.01 grams per mole. And this comes out to 0.11 moles per liter. Or also known as 0.11 molarity. The rest is the same as the rest of part D is the same as the other parts of the question. So the hydrogen ion in solution is the same as the molarity, 0.11 molar. The pH is equal to the negative log of the molarity, which comes out to 0.96. The POH is 14 minus 0.96, which is 13.04. And the concentration of base is 10 to the negative POH, which equals 9.12 times 10 to the negative 14th molarity. So this is the way you can approach these kind of strong acid problems.